Okay there, ladies and gentlemen, let's go ahead and get started. My last video, though, if you watched it, I went through core construction number one and number two, focusing on copying a segment and copying an angle with the concepts and the techniques in that video, really essential to doing the rest of these constructions number three through nine. So if for any reason you did not watch that or are unsure how to do those two things, copying a segment or copying an angle, make sure you go back, maybe rewatch that video or come in, make sure you're asking questions because you need those skills for what you're about to see right here. So let's jump into it. Number three, you're bisecting a segment AB given below. So bisect, remember, means cut directly in half. So again, we're going to use this idea that you're going to be intersecting arcs. Now, in the end, when you're looking at a bisector, you're really looking at a set of points that are equidistant to both A and B. So in the end, we're going to exploit again the property of circles that demands if I cut a circle or create a circle with a given center, every point on that arc is going to be equidistant to A. So in terms of steps, what you really want to do um, is set a compass distance, not necessarily all the way from A to B, but along at least halfway, or excuse me, a little bit more than halfway. So I'm going to set my compass distance here at A, maybe about 2/3, 3/4 distance to B, and I'm going to create an arc. Now I'm not going to create a full arc. In fact, I'm just going to make two little arc markings, one here at the top and one here at the bottom. And the purpose of it being, I don't actually need the entire thing. Like I can use some intuition here, and that's gonna, and if I do, I'm going to realize very quickly that my bisector is going to be about here, about where the middle of that segment is going to be. So I have an approximate placement for my points. I don't need to create the entire arc. In other words, there's no real possible way my bisector is going to line a point that's over here, or it's going to line a point that's over here. Like my bisector is going to be pretty sure to be right down the center-ish. And we're just looking for now precision. So again, step one, set a compass distance, so at least more than half the segment. Create a couple arc markings. Again, picking a set of points they know are going to be a certain distance from A. And again, because we know what a bisector is in terms of being equidistant both A and B, we're going to keep the same distance, flip it over to B, and we're going to create another arc. Again, not going crazy. You don't have to create arcs across the entire page, but certainly we want to make sure that we can see the intersection very clearly. So we'll do one at the top, one at the bottom, because as you well know, you need 2 points to actually create an arc. The 2 points that we will have, not an arc, excuse me, a bisector. So we can mark those 2 points and connect them with a straight edge. So again, I kind of want to emphasize that I just picked arbitrarily a distance as long as I can visually see it's more than half. But we could have gone probably slightly larger or slightly smaller. Allow me to demonstrate. If I increase the distance here so it's a little bit closer to B than before, again, I'm going to be creating a set of arcs, one above and one below, and then matching those arcs with some at B. As you can see, those are falling right in the bisector, as kind of predicted. Again, the advantage of using a compass and how this is even actually working is that this is setting a set radius distance. And as long as I'm picking points that are the same distance from B as they are from A, all those points by definition should be on the bisector. So if I spin this compass much closer, as long as it's going to be at least more than half, I should have equal success. So on this arc are all points that are a certain distance from A. And again, I could draw a whole circle, but I'm not going to need it. And by keeping the same distance and flipping it to B, I'm also finding points that are that distance from B. Since again, points in a bisector are equidistant to the two endpoints, we see again that we ended up with points along that bisector. So very clean concept. One again, we're going to actually repeat right again in section 4. I'm sorry, construction 4. But the idea is we're using the compass to find distances that are the same from two different points. Okay, so without further ado, let's kind of slide down here to number 4. On number 4, we're asked to bisect this segment. Now, the pitfall here, kind of the trap that I'd be setting, is that you might assume A and C are the same distance from B. And that's actually not true. They're very close. It's almost impossible to discern looking just with your naked eye, but I believe A is actually slightly shorter. So what we actually have to do is find a distance from B that's going to be the same. Now, there's lots of ways to accomplish this, but since I don't really have to uh, reinvent the wheel here, all I'm going to do is actually pick a compass distance that's going to be shorter than both. Okay? So I'm going to set this compass distance, so it's going to be shorter than both the distance to A and distance to C, and I'm going to cut an arc across both. So essentially what this has done is pick 2 points from me, ones that I am sure are the same distance from B, therefore is giving me a segment. Okay? So if I connect these, I'm going to connect with a dotted line because a segment, although necessary to this construction, isn't technically part of it. I now have a segment which I'm going to bisect. So let me explain what I mean. I was kind of explaining this in class a little bit. I don't know how clear I was. I would claim the technique we're going to use for number 4 is precisely the same technique that we used up here for number 3. What I mean is, if we manage to bisect this segment, there's other things being bisected. Namely, if I pick a point along that bisector and I connect it back to A and then over to B, I actually create a triangle, but more importantly, I create this angle. So my claim is, if I manage to bisect this segment, I bisected this angle because I'm dealing with an isosceles triangle. Okay? So it should work in reverse. So back down to construction 4, if I pick these 2 points so that this triangle is now isosceles, if I bisect this segment, it's the same as bisecting this angle. In fact, this should really be a point on the segment bisector, excuse me, the angle bisector. So all I really have to do is find a second point. So the technique I'm going to use here is exactly the same. I'm going to pick a distance that's at least halfway from either one of my endpoints. That looks good to me right there. I'll use that to cut an arc. I'll cut it out here, although I very well could have cut it here too. Using the same distance, I'll flip this over to the other endpoint, and then using the same arc distance, or I'm sorry, radius I should say, find the intersection of those arcs. So in trying just to bisect this line, I will in turn bisect this angle. Now, the evidence is going to be seeing if all these 3 of these points line up. If all these 3 points are aligned, then it serves both as a segment bisector of our created segment and the angle bisector of the angle we actually wanted. So that is a way you can actually approach this, is think about bisecting this segment as opposed to bisecting the angle. Which is also why we have to be extremely careful and why picking these 2 points were extremely necessary in this exercise. If we just pick these as endpoints, that's assuming that if I draw a triangle from A to B to C, that's going to be isosceles, which isn't necessarily the case. In fact, I would never assume that safely unless I was told that directly, like the AB is the same distance as BC, which was never stated on this. Again, we saw an extension of that today in class, where, and I'll just sketch it here, where we have one leg extremely short and one leg extremely long. Well, the first step of this construction to do it well is to extend this leg out and then find equidistant points on both. So in other words, extending this line out so it's the same distance as the given bottom leg, and then creating your bisection from there. Um, Again, treating this more like a triangle rather than anything else. Okay, so that's how you bisect a segment and you bisect an angle. But again, the concept was pretty straightforward. It had everything to do with just copying this distance using the compass, um, well, copying the radius. So in the next video, we're going to be looking at constructions, let's see, 5, 6, 7, 8, and 9.